Today we're going to be talking about the rain shadow effect. And in order to do that, we need to draw a diagram of a mountain. So let's get started there. So here's the mountain. And let's assume air is coming in from this direction. So the wind is blowing, and as the wind blows, it forces that air up the mountainside. And because air is blowing into the mountain on this side, we're going to call this the windward side, or wind-facing side. And the other side is going to be called the leeward side. Now, as this wind is blowing up the mountain, this air mass encounters less pressure. It turns out that as you move up in altitude, there's less air pressure. So as this air mass moves up, it begins to expand. And as that air mass expands, the temperature of that air mass begins to drop. Now, the temperature doesn't drop because heat is lost to the surrounding air. The temperature drops because the pressure, because those air molecules aren't as close to each other as they used to be. And that's important. There's actually a term that means that. This is referred to as adiabatic cooling. And adiabatic means that there's no addition or loss of heat going on here. So the temperature of this air mass decreases because the air expands, not because it loses heat to the surrounding air. And that's important to understand. Now, as the air mass moves up here, the air is cooled. And as the air gets cooler, we know that cool air can't hold as much moisture. So what begins to happen is clouds start to form. And it begins to rain. And this side of the mountain is going to be very wet. In fact, it's so wet sometimes it actually forms a cloud forest. So let's write that down, cloud forest. So this side of the mountain is often very lush in vegetation and trees, a beautiful area. Now, as that air makes its way to the top, it has lost, depending on the size of the mountain, oftentimes that air mass has lost pretty much all of its moisture. And when the air mass gets to the other side, it's a very dry mass of air. And once it gets to the other side, that air is going to begin to sink. So let's go ahead and draw that. So our air is beginning to sink now. And as that air sinks, that air mass encounters greater pressure. The surrounding air begins to squeeze this air mass. And as it does, that air mass begins to heat up. Now again, it doesn't heat up because the surrounding air is giving it additional heat. It heats up because the surrounding air is squeezing it. It's doing work on it. It's squeezing it and compressing it, forcing those air molecules closer together. That is referred to as adiabatic heating. And what you end up with here is a very warm, dry mass of air. So warm and dry. Where this side over here was very cool and wet. This is very warm and dry. In fact, this air is sometimes so dry that it creates a rain shadow. And what you get here is a desert. Some of the driest places in the world are created with the rain shadow effect. A notable place would be Death Valley out in California, one of the driest places in the world, and that is created in part by the Sierra Nevadas, a very high mountain range, blocking that wind, forcing that air up and over, and creating extremely dry conditions on the other side. And that's going to be it for the rain shadow effect.